All right, guys, before we get started on today's lesson, are there any questions over the homework? Any questions over the previous homework assignments? We're good? So what we've been doing, we did this a little bit in 313, is solving quadratics. Because when we solve quadratics, we really want to find out what values of x will make the function equal 0. And make the functions be 0. Now, there are several ways that we can solve a quadratic equation in one variable. Our ax squared plus bx plus c, and it's these here. We can solve it by graphing, using the square root method, and by factoring. Now, out of these three here, the main one we have done is factoring, because we can factor it and then solve for the value of x using the zero product property. The other way we can do is use the square root method. We will be going over that in this section 3.3, and by graphing. And whenever we graph it, we're looking for the x-intercepts, where it crosses the x-axis. Because when a graph crosses the x-axis, the y value is 0. It's what values of x will make the function be 0. And we call these solutions roots of an equation, intercepts, zeros. We do have different ways to define or call our solutions. Because if we're graphing, we're looking for the x-intercepts. It's zeros. It's values of x that will make the function be zeros. If we're using the square root method or factoring, we're looking for the roots of the solutions, roots of the equation. But in any case, it's what values of x will make the function be 0. Now, the first one we're going to be looking at is this one here. Our x squared minus x minus 6 equals 0. We're looking for what values of x will make the function equal 0. Now, to graph it, if we were graphing this by hand, we need 5 points. We need the vertex and 2 points to the left and 2 points to the right. Because the vertex is our middle point, axis of symmetry, it will mirror to either side and go from there. The other way is we can use the graphing calculator. So we need to turn that on. And the first thing we're going to do to graph it is hit y equals. First thing we're going to do to graph it, we're going to hit y equals. Very top. So we all get a screen similar to this here. So if there are any functions or anything typed in, go on and clear all of that out. We don't need anything typed in there. Now, the first thing we're going to do is type in this equation. To get x, we're going to click the button next to alpha. Squared. Minus x minus 6. We're just typing this equation into y1. Because it'll let us type this equation in and it will graph it. Is everybody able to get to this point here? Yes? Now the next thing we're going to type, once we get it all typed in, is we're going to hit the button that says graph up at the very top. Questions on this so far? Mm-hmm. Yep. So, what we're looking for when we're graphing, we're looking for the values of x that make the y value be 0, where it crosses the x-axis. And we can see here that it crosses the x-axis at 2 points, yes? One of the spots is negative, it's to the left of the y-axis, and one of them is positive, it's to the right. Now we can try counting those over, or we can go second graph, and it will bring up a table. Second graph will bring up a table. And again, we're looking for what values of x will make the y value be 0. And one of them I already have listed here. And that value is what? 3. So x is equal to 3. Now we need to find the second one, and the other one is what? -2. Let me see. Okay, try it again. So hit graph. Second graph, second table. Yeah, keep going up. Yeah, someone scrolled way down. There you go. So again, we're looking for what values of x will make the y value be 0. And one of them is 3, and the other is -2. Our two solutions for this here are x equals 3, x equals -2. Questions on this here? Because if we wanted to check this here, we could plug those values in, because we can say 3 squared minus 3 minus 6. Well, 3 squared is 9. Minus 3 minus 6. 9 minus 3 is 6. 6 minus 6 is indeed 0. And if we did this with -2 to check it, -2 squared minus -2 minus 6. Well, -2 squared is 4. -2 is +2. 4 plus 2 is 6. And 6 minus 6 is 0. All we're doing here is checking to make sure that these values of x do indeed give us a value of 0 when plugged in. Questions on how we found our solutions of -2 and 3? We feel good with this here. Let's look at the next one. -2x squared minus 2 equals 4x. Unfortunately, we can't just type this in and graph it, because we need this to equal what? 0. Because there's very few methods of solving, especially higher degree polynomials, or x squared, any of these quadratics where what it's equal to is not going to be 0. There's only really 2 methods, and we haven't gone over either one of them yet. And when we do, I will specify and talk about those then. But here, especially with graphing, whenever we're graphing, we need this equation equal to 0. So the first thing we're going to do is subtract 4x, because over here 4x minus 4x is 0. On the left-hand side, 2x squared, -4x, -2. There are no like terms. So we're just going to list it out as -2x squared. Minus 4x minus 2 is equal to 0. Now, if we were graphing or factoring this, we would pull out greatest common factors. We would make that first term negative. But luckily for us, the graphing calculator does not care. So we can pull the graphing calculator up to graph this to find our solutions. And again, our first step is going to be to hit y equals. If we're graphing, the first thing we're going to do is hit y equals. I would clear that out. I just hit clear, erase that a previous equation. And we're going to type it in exactly what it looked like. So -2x squared. Y equals. We're just clear. We'll clear it out. Y equals. Yep, clear. and then we're going to type the new equation in. Questions? Yep. Yeah, it'll go up and down as far as you want it to go. And just type the new equation in. So negative 2x squared minus 4x minus 2. Negative 2x squared minus 4x minus 2. If that first term is negative, we have to use the negative. We can't use the minus. Questions on this so far? Is everybody able to get the function typed in? Okay, very good. Yeah, unfortunately, we can't use negatives as minuses and minuses as negatives. Because if we put negative 4x, it's going to think you're multiplying those two together. Once you get it typed in, we're going to hit graph. Hit y equals negative 2x squared. Let's see here.
What did you do?
That needs to be a negative. So negative.
Oh, I just
2
minuses. Okay, yeah, that's what you
x.
got that.
That should be 4x. Yep. Here we go. Did we get the second one typed in? Y equals.
I keep
There
putting.
we go. Yep. So negative 2.
I know what I'm doing. I'm just doing it wrong.
The issue that came out for the first one is if you put a minus for that x squared in front of the minus instead of the negative 2, what the calculator is looking for, and the reason it gave you the error, is it's looking for a number in front of it. So minus 2x squared, it's looking for a number term to be in front of it. Since there's not one, it throws an error. So, can I borrow your pencil? Because again, yep, we have to get that equal to 0. So we had 2 minus 4x on both sides. And now we type that whole thing in. Zoom, so 6. Zoom standard. So guys, questions on this so far, and I'm going to answer this, why that window looked wrong. If, for some reason, again, guys, up here, again, other people are using these calculators, so the screen might look graph might look a little different. Zoom, the button in the dead center, if you notice number 6 is Z standard. If the window looks off, I would use Zoom standard. What that's going to do is put the x-axis from negative 10 to 10. So the two ends are negative 10, positive 10. The y value is going to go from negative 10 to 10. So it gets us that picture. So if it's ever off or just looks weird, Zoom standard. So looking at this here, again, for us to solve by graphing, we need to see where it crossed the x-axis. We're looking for what value of x will make the y value be what?
What did you do again, second graph?
Second graph to get the table.
We're looking for 0.
On the x or y? It's the y. Second graph. Graph will give us the graph. So go scroll down. Keep going. Second graph will give us the table. And when we're solving by graphing, we're looking for what value of x will make the y value be 0. We're looking for what value of x will make the y value be 0, not when the x is 0. The only time we care if x is 0, if y is also 0 at that point. Here, x is negative 1. Yep, nope, I just didn't put it back on your desk. So x is negative 1. Now, if you notice on the graph how it touched the x-axis but did not cross it, that's the only solution. It actually has a multiplicity of 2, an even multiplicity. There's technically 2 zeros there, but we only have to list it once. So x equals -1 is the only solution for this here. Questions on this one here? Let's look at the next one. X squared minus 8x plus 12 equals 0. This is nice. It already said equal to
Yeah, it's already equal to
0. So we don't have to make it be 0. Now the first thing we can do is hit y equals. And we can clear out the other equation. X squared minus 8x plus 12. X squared minus 8x plus 12. Once we get it typed in, you'll go on and hit graph. How many times does it intersect or cross the x-axis? Twice. We see 2 places there. Are they positive or negative values? Positive. So we're going to look for 2 positive values. Now we can count on the x-axis, or we can go second graph to look at the table. So what values of x will make the y value be 0? 2 and 6.
3, 6, 9,
So x is equal to 2, and x is equal to, those are our 2 solutions. Questions on this here? We ready for the next one? So 1/2 x squared is equal to 6x minus 20. We need to get this equal to what? 0. So here we can subtract 1/2 x squared because we're going to add or subtract things from both sides. Either add something to both sides, subtract something to both sides to move something from one side to the other. Here, if we subtract -1/2 x squared from both sides, the ones on the left simplify out, become 0, and give us -1/2 x squared plus 6x minus 20. Questions on how we got to this point here? So the 30 or the 84 TI 84 plus will let us do fractions. Yeah. So alpha y equals enter. Alpha y equals enter. Yes. Now the 30xs, the one main difference is it won't fractions.
Okay,
So the
yeah,
83s.
there is fraction.
Yep. So yes. Alpha y equals enter. Let's follow along. So we're able to get this. We good with this here? Okay. Now, in the graphing calculator, the first thing we'll do is hit y equals clear. Now for the 84 plus, alpha y equals enter will give us a fraction. The TI 83s, the ones that y'all can check out take home, the big difference between the 83 and the 84, it won't do that. It won't let us write it in as a fraction. So what we can do instead is turn that decimal into that fraction into a decimal. Yes. But here, luckily, we can type it in as -1/2 x squared plus 6x minus 20. Now, if we were trying to factor this, we would really want to get that negative 1/2 to be a whole number. We would want to try to change it. But luckily, graphing, it does not matter. The graphing calculator will take it as negative 1/2 x squared. Or if I want to put it as negative 0.5 x squared plus 6x minus 20. This is the same problem, the same function. Questions on this here? Now, there is another way we could type it in. It's mainly, again, I'm just revolving around that. I don't need it there. I could go parentheses negative 1 divided by 2, because that is what negative 1/2 is. It's just 1 divided by 2. X squared plus 6x minus 20. You don't need all these different versions. You just need one. Because if we graph, it was kind of quick, but if you notice that graph changed colors 3 times, or it graphed it, changed it, and then changed it again. So if you look at the graph, blue, red, black, it's just the same function. So, questions on this so far? Where does that graph cross the x-axis? It does not. So what we say for this one here is that this equation has no real solutions. So negative 1/2 x squared plus 6x minus 20 has no real solutions. Now that is not the same thing as no solutions. It just has no real solutions. There are solutions for this equation. The solutions are just not real. And that'll make more sense after Thanksgiving break. We'll get to that after, or not Thanksgiving break, fall break. We'll talk about that after fall break and specify and dig into what a non-real solution is. So if it's not crossing the x-axis, it means we have no real solution. Questions on this here? Four x squared minus 12x plus 9. So again, we can grab the graphing calculator. Type in y equals 4x squared minus 12x plus 9. X plus 9. It hits it, it's just right there. Yes. So, if there is a solution, and there is, it's going to be between 1 and 2. Because if there's a solution, it has to be between 1 and 2. Because that's most likely where 0 occurs. Now, there is a theorem called the intermediate value theorem. And according to the intermediate value theorem, it doesn't show up here, if we're looking at a table or we're looking at solutions, and the x values, as we are increasing, going 1, 2, 3, 4, going down, or decreasing in either direction, and the values of y go from positive to negative, or negative to positive. But what's the only way that the y values can go from positive to negative or negative to positive? Is if it crosses the x-axis. The y value has to be 0 at some point between them. So according to the intermediate value theorem, the x values to where it goes from positive to negative or negative to positive for the y has to be a solution. That's all the intermediate value theorem says. But there is some solution there, yes? Is the graphing calculator helpful for finding this? No. So graphing does work very well if our solutions are integers, are nice numbers. I will show you this here. So, second window, second table set. Second window. Now, I would watch this because, again, this is going to need a little bit, you need to have a little bit of insight to know to do this. But what this is saying that the table set, as it goes in the x's, it's going to increase or decrease by 1. I'm going to tell it to decrease by a half or increase by a half from one to the next. So instead of going from 0 to 1 to 2 to 3 to 4, it's going to go 0 to 1/2 to 1 to 1.5 to 2. It's going to go by halves. Second graph, I went back to the table. So 1.5 is 0. Now the reason I said you have to have a little bit of insight into this is because I knew that we were going to have to be dealing with a half. That 1.5 was going to be the solution. Because if it wasn't, going by halves might not be helpful. But before we end or get to this here, but as we can see here, some of the graphs are not going to be helpful. Because if they are these fractional, these decimal numbers, we might not get the solutions. So, graphing works for a good number, but not for all of them. Now, if we look back at this here, 4x squared minus 12x plus 9. We can factor it. If the third term is positive, the signs are the same and match the sign of the middle term. So here it would be negative and negative. Our factors are 4x squared, x and x. 4 is 1 and 4 or 2 and 2. Here we'll use 2 and 2. 9, we have 1 and 9 or 3 and 3. If I check this here, 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. That is the correct middle term. So this is, again, referring back to our 3.13 where we factored and then solved. So according to the zero product property, if two or more things multiply together to equal 0, one of them must be 0. So either 2x minus 3 is equal to 0, or, yes, 2x minus 3 equals 0. We can add 3 to both sides, telling us 2x is equal to. Okay. Divide both sides by 2. Telling us x is equal to 3/2. And if we solve the other one, so like the one we had earlier where we found one solution, what that's telling us is it's touching the x-axis but not crossing it. That's why we have the same solution for both. Questions on this here? So we good with this so far? Okay. Solve each of these using the square root method. Now, if we solve this by graphing, we would need to get this equal to 0, yes? So I wouldn't write this down. I'm going to show you how to do this by graphing, so don't write this. We would subtract 49 from both sides, telling us that 4x squared minus 80 is equal to 0. So again, I wouldn't write this down. And we can take the graphing calculator. dy equals 4x squared minus 80 graph. Does that give us nice points? No, it doesn't look like those are nice values of x. Okay. So again, as we said, factoring or graphing doesn't always work.
Yeah, I don't think it works for this one.
Did not work for this one. Now I can try factoring. And again, I could factor out a 4. So I wouldn't write this down yet. Because we could subtract the 49, this is the equation we have. I can factor the 4 out, because there is a greatest common factor of 4, which does give us x squared minus 20. We have two terms being subtracted, yes? X squared, is it a perfect square? What times itself is x squared? And x, so x squared is a perfect square, yes? What times itself is 20? And we can check. We can go second square root 2 squared roots of 5. That's not a perfect square. So even though we have x squared minus a number, it's not a difference of perfect squares because we have this radical. Even if we tried it before factoring out the 4, it's still not a perfect square. So what that tells us is that it's not a difference of perfect squares. So that means, well, factoring, we just threw it out. So factoring does work on some of these here, but not all. Graphing works on some of these, but not all. There's only 2 methods that work for all equations. But there is one thing that is nice about this equation. We are missing what? We're missing a middle term. We don't have a term with x. So, yes, yes. So we're able to see that this equation does not have an x term, a middle term. It would be 0x. Now, if there is no middle term, we can solve by the square root method. Square root method is one of the only 2 ways where we can solve this without it equaling 0. If there's no middle term, we can use the square root method. And the first step is to get the squared term by itself. And that's either going to be x squared or a set of parentheses squared. So if we want to get that x squared term, that squared term by itself, well, the first thing we have to move is the negative 31. And we can do that by what? Adding 31 to both sides. Because negative 31 plus 31 is 0, leaving us with 4x squared is equal to 80. Is our squared term by itself. Is what's with our squared term. The 4. So we need to divide both sides by 4. So that will tell us that x squared is equal to 20. Questions on how we got to this here? So we feel good about getting this point. Yes? Well, what did we call this method? We called it the square root method. Because once we get the x squared or the squared term by itself, we're going to take the square root, or we're going to take the square root of both sides. And the reason we do this is the square root of x squared. What's the square root of x squared? X, because the square root and square will simplify out. Because the square root, when we take the square root of something, we're looking for what times itself. And we just did the square root of 20. So square root of 20 is 2 square root of 5. Because if we can reduce it in any way, we're going to reduce it. Now we said it crossed the x-axis in 2 places, yes? When we square root both sides, when we take an even root of both sides, we have to add a plus or minus. We have to add the plus or minus. Because when we take a square root, we're saying what times itself is 20. It could be negative or positive. Because, and we can look at this in the calculator, 2 square root of 5 squared is indeed 20. Negative 2 square root of 5 squared is also 20 because we're multiplying it by itself. And when we multiply a negative by a negative, it makes a positive. Now for geometry, when we took the square root of both sides, we didn't put the plus or minus for most of those there because we're looking at a distance, a length. And a distance or length has to be positive. So we never considered the negative case because in the context of the problem, it didn't make sense for the length to be negative. Pure mathematically, it could be positive or negative. Because if we took, say, the square root of 9, square root of 9 is 3, but it could also be negative 3, positive or negative 3. That's why with our difference of perfect squares, we have the positive or negative case. Solve for x, solve for the variable. So looking at this here, is the variable by itself? So we solve for it. So this here, x is equal to plus or minus 2 square roots of 5. We will stop there for today. We're going to do more of these here. Before y'all put the graphing calculators up, one thing I do want you to do is second window, and make sure the table is back to 1. So if you didn't change it, it's not going to make any difference. But if you did, just scroll down, make sure it's 1. Yep. We can just make.
Does the table start for negative 3?
It doesn't matter as long as it's not a decimal. So negative 3, 0, negative 11. That's fine. All that means is when you hit graph, it's going to be the first number that pops up at the top. So if it's 0, the first number is going to pop up as 0. So it doesn't really matter. That table set needs to be 1.